My name's Carole Tucker. I'm a professor at Cardiff University and I've worked for 25 years in the Astronomy Instrumentation Group. Oh, it's been a real honour and a slight surprise to win the James Joule Medal from the Institute of Physics. But I accept it on behalf of a team that I lead, and that team is terrific. It's a skilled, highly dedicated team, and so it's a great honour to accept that award on behalf of them and share the prize with them. Describing the work in a nutshell is always a challenge, but the award, I think, builds on 25 years of activity to help enable far-infrared astronomy, and specifically the instruments that we build for that. So my role has been developing the specific type of optical filters that are needed to let through the light that the telescope has to see, but block out everything else. And we, fantastically, are the sole world providers of that technology. So that means that we have bought in to virtually all far-infrared space projects and ground-based projects and other terahertz science over the years. And most strikingly, I think everybody's impressed when they hear that our devices go into space. So two relatively recent projects were the Herschel Space Observatory and the Planck satellite, which launched in 2009, but they had actually hundreds of our filters on those telescopes. So those projects were really important to Cardiff University as a whole, because it wasn't just us leading the technology, but also the scientists working on the data analysis and coming up with the new scientific discoveries. A lot of those people were also at Cardiff. So it's always really fascinating, and maybe not surprising, that when you develop state-of-the-art technology for scientific endeavour, ultimately many of those developments will find application for real-world projects. And it's a delight when you see that application closer to home. So, for example, it's not just doing astronomy that these filters are relevant for, but they can be used to study to make studies of the Earth's atmosphere. Again, you know, a satellite looking down through the atmosphere and finding out about the latest meteorological developments. They're also used in nuclear fusion diagnostics, so next stage energy. They have been more recently used on a human security screening development, a new camera for human screening. And that's also very interesting for Cardiff, because that's another spin-out company that Cardiff University is involved with. So an exciting development is that we have now formed a spin-out company called Celtic Terahertz Technology to take on the full facility of the filter and optical manufacture. And we've had to do that because of success. When I started in this technology, devices were quite small, maybe an inch, and these days we're required to make half-metre devices. We also now need to make hundreds of devices, and so that whole facility doesn't really fit within the university environment, which should be concentrating on R&D. So it was a great opportunity to now spin out the company, but keep it within the confines really of Cardiff University. We're very close to our department. We can still work with the people and the scientists that we've collaborated with for years. And it's a fantastic opportunity, I think, for Wales and UK technology. We're working on a few things at the moment. There are always the next generation of astronomical instruments being designed and talked about, and so one exciting development at the moment is the hope that NASA will be funding a new far-infrared space observatory which should launch in 2030, and we're working with the teams in the US and around the world, designing the basics of the instrument and how it will work and what frequency ranges it will cover, and so our filters are fundamental to those discussions. So I really look forward to seeing another launch in, you know, maybe 8 to 10 years' time.